In an earlier tutorial video, we built up a little toy train. The method used was to build up one piece at a time, starting with the top deck and just glomming each piece on or cutting away as necessary until the very end we got our final result. The problem with this method is if we were designing from scratch, it wouldn't allow us to see what the train was going to look like until we got to the very end of the process. Furthermore, because we are just gluing one piece onto another using previous features to drive the parametrics of later features, we have a situation where it is often very difficult to move many of the features up and down the feature tree due to parent-child conflicts. For example, if I try to take the front wheel and move it in front of the drive wheel, I'm blocked from doing that. Or if I want to move the drive wheel in front of the undercarriage, I can't do that either. This new tutorial shows a method where we plan out all of our work ahead of time using layout sketches. We then borrow elements from the layout sketches to create all of the various features. Here, for example, we see a layout sketch that shows what the train is going to look like on the front plane and what it looks like on the right plane. And then just to give an example of what the first feature would look like, in this case the cab, we'll edit the sketch. These lines in the sketch are being borrowed from the layout sketch and controlled parametrically by the layout sketch. There are several advantages to doing this. The first is that by placing all the major features in one layout sketch, the overall design can be appreciated and adjusted before any of the features are actually created. This allows us to plan out our work. The second is that there is no need to be changing a lot of features in a trial and error process when adjusting the proportions and relations of features with respect to each other. Everything can be changed right here in one sketch. For example, let's say that I decide that I want the cab to have a sleeker look to it, not so tall as we see here. I can take this dimension and move this down. Suddenly I realize now that the boiler is going to be too tall for a cab that's this low. Instead of having to then go back and change a boiler feature, which I would have to do using the other method, I can right here in the same sketch tweak the proportions of the boiler in order to fit with the new proportions of my cab. This is just like working on a sketch pad where I draw on lines and erase them, move them around, and I do it all in one place. Later on, when I'm happy, I put a piece of tracing paper over it and draw my final result. Finally, by relating all the features as much as possible back to the layout sketches rather than to each other, eliminate a large number of the parent-child conflicts. This allows more freedom later on to move features up and down the feature tree as required by the design. For example, in the earlier method, there was no way I could build a smokestack before I built the boiler. If I wanted to, I could actually now take the smokestack, because it has no relations back to the boiler, and move it well up just about anywhere I want in the feature tree, even before the boiler feature, step 6, without any kind of parent-child conflicts. Of course, I don't see a reason to do this in this particular case, but one reason that we might want to do this is a lot of times it's nice to be able to organize our features in logical groupings after we've completed our design. For this tutorial, you've been given a starter file that consists of nothing but the front layout and the right layout of the train. We can see that features in the right layout have relations to the front layout, so that any features represented in both layout sketches align with each other. For example, the top of the cab in the front layout aligns with the top of the cab, in the right layout aligns with the top of the cab in the front layout. Similarly, the bottom of the undercarriage in the right layout aligns with the bottom of the undercarriage in the front layout. I'm going to start this process by creating the cab. This is done by starting on the front plane, making a new sketch. What we want to do is copy the appropriate lines that represent the cab from our front layout into our new sketch. This is done by using the Convert Entities command. This takes any previously existing sketch elements or edges of solid elements, and it copies them into our sketch from the point of view of our sketch. So if I click on this line here and click Convert Entities, what it's doing is copying that line into our sketch, and it retains a parametric relation to the original layout. So if this line gets moved or shifted in the original layout, it will move in this new sketch. So I need to use this line, this line, this line, this line, and this line, and I also need to cap this off with a bottom line. I'll hit Convert Entities and just select each of the entities that I want to convert, and I'll hit the green check mark, and it's copied those elements into this sketch. Now in this case I need to finish this off with a line on the bottom. So I'm just going to draw a line from this corner point. I'll drag it out to here so we see that this line and this line are overlapping each other, and I will just take and trim the excess away. You also have one other case here where we need to trim the excess away. What we're left with is one contiguous set of lines that form a 2D zone, and this will become our CAD. So you see we've copied a lot of lines, which gives us this on-edge relation that happens when we use Convert Entities. In a couple of cases we had to add a line and trim back some edges. Now it's going to be time to do our actual extrusion. Before, you remember in the previous tutorial we used the mid-plane extrusion. Now what we're going to do is actually use our right layout sketch to control what the depth of this extrusion is in the two directions. Go to Features, Extrude, and instead of using blind, this time we're going to use up to vertex. And we can choose either this vertex or this vertex because both represent the width of the cab in this direction. So I'll just choose this upper one here, and I'll activate direction 2 up to vertex and select this point here, and that completes my cab. So you see I've created this feature without adding a single dimension to it because all the dimensions were previously controlled or created in the layout sketches. The next feature I want to add is this top curving cut. So I can just click on this face here, or even better, click on the right plane, sketch, and just simply copy this curving line. And just like before, use the extruded cut command. Make sure that the arrow is flipped upward. And that cuts away the top of my cab. Once again, I added no dimensions at all because they were previously created in the right layout sketch. Now I have a lot of choices about what I want to do next. I could always make the boiler next, or make the undercarriage, or the deck in this portion here. It doesn't really matter because of this method that we're using. I'll just go ahead and make the top deck, but I noticed from my layout sketch that I might as well just go ahead and make this little piece here at the same time. Before, when we made the train, this was added on as a separate part. Now that we have the layout in front of us, we can sort of see what is the logical way to build these parts and take advantage of that. So rather than building these as two separate features, I might as well just make them one. In fact, I might have even considered making the entire cab, this deck, and this front portion all one extrusion if I wanted to. So once again, going on my front plane, sketch, and the lines I need, I'll use Convert Entities. The lines I need are this line, this line, this line, and this line. Also this bottom line and this back edge line. We see that this does not go quite as far as we want it to go. So even though we've copied this line from the previous layout sketch, it turns out that we can drag the endpoints of that line and it will still retain a parametric relation to the original layout. As long as we have a free point at the corners, we can still drag these and the location of the line will remain collinear with the original layout. So I'm going to extend this line upwards so it hits this line. I'm going to use Trim Entities and get rid of the excess bits that I don't need. So I'm going to trim this away, and this away. They still retain parametric relations to the front layout, and we see now what we have is an L shape that we're going to extrude. Before, in the original tutorial, we used the up to surface feature when we extruded the deck in order to guarantee that it was at the same width as the cab. If we do that again, what's going to happen is this deck is going to have a child relation to the cab. I'd like to avoid that, instead give it a child relation only back to the original layout sketches. So being that the cab was extruded up to this vertex and to this vertex, I'm going to do the same thing with this deck, which will guarantee that the deck is at the same width of the cab. And if later on this sketch gets changed, both the cab and the deck will update together. Up to vertex, direction 2, up to vertex, hide all the sketches for a moment, and we see that the deck and the cab are the same width. Now we might think that this deck is a child of the cab. In fact it is, but not for the reasons that you would think. The reason before it was a child of the cab was largely due to the fact that we had an up to surface extrusion where we would have extruded the deck up to this surface of the cab. In this case, the only reason that this deck is a child of the cab is because the two are merged together, and the cab had to exist in order to have something for the deck to merge to. If I were to go back into this feature and edit it and uncheck merge, that makes this a separate body from the cab. And if I go back and check the parent-child relations, I see that the only parent of the deck is just the layout sketches and not the cab, which is this boss extrude 1. This is just a problem that usually exists at the very beginning of the feature tree, because usually the very first feature is going to be the parent of all the other features because it's the one that everything gets merged onto to start with. But once we move along, we'll see that using this technique we can separate our parent-child relations pretty effectively. I'll just go back, edit this feature, and remerge those together so that this is one single body. Moving along, I think the next thing I will make is the undercarriage. On the front plane, I'll make a new sketch. And once again, I will copy from the layout the appropriate lines from the front layout. And again, when you do this, a lot of times you have extra pieces left over because of the nature of the layout. All you have to do is trim away whatever is not desired in order to create a contiguous set of lines that form a 2D zone. Now I'm going to go ahead, extrude this, and again go up to vertex here in this case, direction 2, up to vertex to this point here. Now we'll take a look at this once again at the parent-child relations. We see that the only parent-child relation is to the boss extrude 1, which is our cab, and to our two different layout sketches. There's no parent-child relation between the undercarriage and the deck here as we would have had in our previous tutorial. So we can just keep on moving along using this method. I think in the sample file provided I actually made the boiler before the undercarriage, but it hardly matters. So on this plane here, or on the front plane, the right plane, I can go ahead and make a new sketch. I can go ahead and just copy this circle, which represents the boiler, and extrude it up to this point. Or if I wanted to, I could even draw on the front plane, copy these lines and this line here, and do a revolve to create a boiler as well. So you see that this method again gives me a lot of choices that I can plan out just by looking at the nature of my sketches. So I'll just go ahead, convert entities. Accidentally grabbed the wrong lines here. Incidentally, what happens is if you click on a surface and click convert entities, what it will do is find all the edges of that surface automatically. We're not going to do that in this case. What we're going to do is click on this circle, convert entities, and now we're going to just extrude that up to vertex. You can choose this point here or this point here, and there's our boiler. We can go ahead and start drawing the wheels on this surface here by again copying the wheel sketches from the layout. But if we don't want the wheels to have a parent-child relation to the undercarriage, what we can always do is first create a new plane which is parallel to the front plane and passes through this point. Then we can place the sketches for the wheels on that new plane and have the wheels be completely independent from a parent-child relation standpoint to the undercarriage. I'll just go ahead and do that. So I'm going to make a new plane. Front plane as a first reference. This point, which is in the layout sketch, the second reference. We have to be careful we don't accidentally grab the undercarriage. And then go ahead, make a new sketch, and I can just click on the wheel, convert that, and when I extrude it, once again up to vertex, I'm going to use either this vertex or this vertex to control how far that wheel is extruded. I can do the same with this wheel and then pattern it, and then when I'm completed I can go ahead and mirror those to the other side. I won't show all that in this video since you already know how to do that from the previous tutorial. I'm also going to skip over the making of the cow catcher and the little front headlight and just talk for a moment about the smokestack. Here you see I've drawn only vertical lines to represent the smokestack, even though the finished product we know is supposed to have a smokestack shape like this. It isn't necessary to get every single detail into our layout sketches, just enough to guide us on the major details and proportions, and then finer details can always be added in the actual sketches that are used to make the features. So for example, when I make the sketch for the smokestack, I can go ahead and copy this line. Then I can add the other lines that are necessary to complete it. So the layout sketch will still control the location of the smokestack and even what its thickness is down at the base, but these finer details, such as this upper portion here, I can always add to my sketch. And as you get experience using layouts with Solidworks, you'll develop a feel for how much detail you should put in the layout and how much detail is best left for the actual feature sketch. So I'm going to drag this line down here a little bit. I'm going to copy this line using convert entities. I'm going to convert it back into a construction line by clicking on it, clicking on for construction. And I can use this now to dimension the other portions of the smokestack. I won't worry about what the proper dimensions are there, but then just like before, you can use the revolve command, make that a thin revolve, and that completes our smokestack. Going back to our completed model, we can see now that, as I said before, we can move several of the features at will up and down the feature tree. I can move this wheel plane. Well, okay, not the wheel plane, but I can move the drive wheels into different locations. I can move the smokestack into different locations in the feature tree. I can do the same with just about anything. Here I can move the cow catcher well up and down the feature tree if I like. What I can do with this freedom is to group things together in logical groupings. So here I see the cow catcher requires 2 features to create it, so it's nice to have those 2 features next to each other in the feature tree. So what if I want to change the look of my train? Instead of going into each of these features now and adjusting all the different sketches, all I have to do is go into the layout sketch and make my changes here, and because all my features are parametrically linked to the layout sketches, they will automatically update. So let's say we want to make our train longer. can do that. Say we want to make the cab taller. We can do that. And let's say just for some reason we didn't have the end of the boiler dimensioned with respect to the end of the train. Maybe we only had the boiler being given an absolute dimension like that. If I were to make some change to the length of the undercarriage, I would see that the boiler wasn't moving with it. I would realize right away that my method for dimensioning this wasn't very good. This tells me right here in this one sketch there's probably a better way for me to dimension this, which is to dimension the front of the boiler with respect to the front of the train. And then I can see just in this one sketch how things will update all together at one time, rather than having to find out after exiting a sketch and rebuilding. So now I'll hit the rebuild, and here we see the entire train has updated automatically without me having to go and change any of these features. If I want to change the width of the train, I can go into the right layout. I'll change this from 3 to say 4. Hit the rebuild. And here we see the entire train has gotten wider, and not only has the cab gotten wider, but the deck has gotten wider and the cow catcher has gotten wider as well. And even the wheels have gotten wider at the same time because of the way that the layout sketch was designed. This is how you're going to want to start designing all of your future projects, even though this is a very simple one and it's not required, because as you get more and more complicated designs, you'll find that this is the easy way to make updates to them, also to communicate to any of your team members, if you're working with any, exactly what your design intent, because they can see everything right here in your layout sketches.